Alright, welcome back. In this video, I just want to take some time to talk about the difference between independent and dependent power sources. So independent sources are the ones that we're familiar with so far, so that being the independent voltage source and independent current source. So independent voltage sources, and these are ideal, what they do is they guarantee a certain amount of voltage difference between the terminals, and they'll use any amount of current to make sure that that happens. So say this is a 9-volt battery. If you connect it to a resistor or something, depending on the resistance of that resistor, it will force through as much current as necessary to ensure that this battery is, like these terminals, or the positive terminal is 9 volts higher than the negative terminal. And ideal independent current sources also work basically the same way, but what they do is they make sure that a certain amount of current is always flowing through, and they'll make sure that the voltage across it is whatever it takes to ensure that that current is flowing through. So again, if you have a resistor here of some amount of resistance that's connected to it, and this is specified to 2 amps or something, depending on the resistance provided by the rest of the circuit, the voltage across this will be whatever it takes to make sure that that current stays constant. So these independent power sources will do whatever it takes to maintain their constant values with no regard to what's going on in the rest of the circuit. But there's something called dependent sources, and they can provide a certain current or voltage, but it's going to be based off of some other condition in the circuit, not just this element itself. So the first dependent source that we can talk about is called a current-controlled current source. And for all dependent sources, we're going to use a diamond shape instead of a circle shape. But what happens with this is, rather than just putting out a specified amount of current, again with no respect to what else is going on in the circuit, it's going to depend on something else. And in this case, it's going to depend on a current somewhere else in the circuit. So if we just label on another part of the circuit that this depends on, that's going to have its own current, then we can call the current flowing through that part of the circuit the controlling current. And then the current that's flowing out of this dependent current source we call the dependent current. So sometimes we give them the subscripts of I in and I out. And I out is just going to be equal to some multiplying factor times I in. So some people will give it, specifically for a current-controlled current source, we'll use the letter beta. And this is actually a unitless value, because if you just rearrange, you can see that beta is just equal to current out over current in. So it's amps divided by amps, and this actually has no units. But it's just going to be a multiplying factor. So some people will also call it a scaling factor or an application factor. But you don't even have to really worry about remembering that this thing is beta, because sometimes you also might see it written like this, where we just call the controlling current maybe something like Ix, and then you would call the dependent current, it would just be labeled on something like this, where it's like 2Ix. So in this case, the multiplying factor would be 2, and whatever the current is over here, we're just going to put out twice as much over here. So really these problems actually, when you first are introduced to them, they seem a little bit complicated, but they're actually quite straightforward. So let's just label on this too, this is unitless. Okay, so there's another type of dependent current source, and we call that the voltage-controlled current source. And again, we use the diamond shape, and this current source is just going to put out a certain amount of current, but it's going to be based on another voltage somewhere else in the circuit. So we call the voltage the controlling voltage, and we call the current that it's putting out the dependent current. And again, the dependent current is just equal to a multiplying factor times the controlling voltage in this case. And some people will give this the letter alpha, but again, you might often just see it written something like this, where we have Vx as the controlling voltage, and then the dependent current would just be something like, again, 2 times Vx. Or 0.5 times Vx or something like that. But you can see if you rearrange this, you get alpha is equal to current divided by voltage. So that means that alpha is in units of Siemens, which is the same thing as 1 over ohms. Okay, so these are our 2 types of dependent current sources. And we also have some types of dependent voltage sources as well. So the first one is a current-controlled voltage source. And again, we're using the diamond shape for this element. But the voltage that it's putting out depends on a current somewhere else in the circuit. So we also use a multiplying factor as well. And for current controlled voltage sources, it's common to use rho if you're specifying an actual letter for it, but also the letter might not always be written in the problem. So again, you might just have a current and it could just be called IX or something like that. And then again, your dependent voltage could be called just something like 2IX. Again, this is just a constant and it could be anything. It could be 2, it could be 1, it could be 0.5, etc. But the multiplying factor in this case will always be in units of ohms. Because if you rearrange it, you can see that we have voltage divided by amps, and that has to be in unit of ohms. So that leaves one last variation for a dependent voltage source, and that is the voltage-controlled voltage source. And again, we're using a diamond shape, and like it sounds, the dependent voltage in this case is controlled by a voltage somewhere else in the circuit. So the expression that we have is just the dependent voltage is equal to our multiplying factor times our controlling voltage. And in this case, you can see that if you were to rearrange to solve for our multiplying factor, it would have to be unitless because it would just be equal to voltage divided by voltage. And with this one, people like to use the letter mu, but also, again, you don't have to memorize all 4 of these letters because often, again, you're just going to be given some voltage with unit of volts, and then you're going to be told in the problem that this dependent voltage is something like 2Vx. Or again, it doesn't have to be a 2, it can be anything. But you don't have to, you often won't even see these letters showing up in problems, but if you want to be really proper, then you can know them as well. So when you're solving these problems, what you have to do is you have to figure out what the controlling voltage or current is for the type of dependent source that you have. And usually you're given the multiplying factor. So once you find the controlling voltage or current, what you do is you just multiply the multiplying factor to it, and then you'll have your dependent voltage or current as that power source, and then you'll be able just to proceed with the problem as usual, just as if it was like another, just a basic independent current or voltage source. So yeah, I think that's it for now, just some vocabulary. These acronyms are good to remember if you can, they're pretty straightforward, but otherwise I'll see you in the next couple videos and we'll go over one example for each of these.